Hello students. Uh, in this class we will discuss about uh, isentropic flow. As you know, isentropic flow is a flow condition without any uh, entropy change. So this figure here shows a process from 1 to 2 which is isentropic, and the properties of process 1 is V1, P1, T1, rho 1 and E1. E1 is the total energy at state 1, and the corresponding values at 2 is P2, V2, T2, rho 2 and E2. And we also know that the stagnation condition of any state is nothing but the when we isentropically decelerate the state to a zero velocity, then that condition is called stagnation condition. So here in this case, V01, P01, T01 etc. are the stagnation condition of state 1, and V02, P02, T02 etc. are the stagnation condition for state 2. And the important point we have to remember in isentropic flow is that the stagnation condition for both these states are same. That is, P01 will be equal to P02, T01 will be equal to T02, rho 01 is equal to rho 02, E01 is equal to E02. This is only possible in isentropic flows. In other flows that we will discuss later, this is not possible. But in isentropic flows, the stagnation condition at any state are same. Now we are going to derive some expression for isentropic flow. First one is change in entropy. In isentropic flow we know that it is 0. So we can write Cp ln T2 by T1 minus R ln P2 by P1 is equal to 0. Then we know that Cp is equal to gamma R by gamma minus 1, Cv is equal to R by gamma minus 1. Then substitute these things, that is expression for Cp in this equation, we will get P2 by P1 is equal to T2 by T1 whole raised to gamma by gamma minus 1. So this is any valid for any isentropic flow. So we can write P0 by P is equal to T0 by T raised to gamma by gamma minus 1. In any isentropic process, this expression will satisfy. Now another expression for entropy change is Cv ln T2 by T1 plus R ln V2 by V1, and for isentropic process it will be equal to 0. Then we will get another expression, that is rho 0 by rho is equal to T0 by T raised to 1 by gamma minus 1. Okay, so you have to write all the steps in your notebook. Next is energy equation. Energy equation is the total energy remains constant. We are assuming there is no heat transfer, work transfer, and datum. Z1 is equal to Z2. Then we can write the energy equation like this: H0 is equal to H naught means stagnation enthalpy is equal to H plus V square by 2, right? That is equal to H naught is Cp T0, which is equal to Cp T plus V square by 2, and the Cp is gamma r by gamma minus 1, and substitute the value for Cp in this expression. Finally, you will get an expression T0 by T is equal to 1 plus gamma minus 1 by 2 m square. Why this m square? V square, m is Mach number, V by A is Mach number m, then V square by A square is equal to m square. So this expression T0 by T is equal to 1 plus gamma minus 1 by 2 m square is the important equation in compressible fluid flow. Similarly, we know that P0P is equal to T0 by T raised to gamma by gamma minus 1. Then P0 by P in terms of gamma and m, 1 plus gamma minus 1 by 2 m square, which is equal to T0 by T raised to gamma by gamma minus 1. Similarly, rho 0 by rho we can write 1 plus gamma minus 1 by 2 m square raised to 1 by gamma minus 1. And at stagnation condition, the velocity of sound is equal to root of gamma r T0, and T0 is the stagnation temperature. Next, one dimensional flow equation. We have already derived this one dimensional flow equations. Assumptions are steady flow, no body forces, no work transfer, and constant area duct. Then mass equation comes to rho 1 V1 is equal to rho 2 V2. Momentum equation is P1 plus rho 1 V1 square is equal to P2 plus rho 2 V2 square. And energy equation comes Q plus H1 plus V1 square by 2 is equal to H2 plus V2 square by 2. Okay, so these are the three one-dimensional equations for isentropic flow. Now, another important term used in compressible fluid flow is characteristic Mach number. So you consider any streamlines shown in figure, any streamlines, and consider any fluid element which velocity at an instant is v and Mach number is m and temperature is T. Then assume that an imaginary state can be reached by this fluid element by either slowing down its speed or increase its speed, because if it is supersonic flow, you have to slow down the velocity of particle to reach sonic velocity, or if it is subsonic flow, you have to increase the velocity to reach sonic velocity. So an imaginary state can be reached by slowing down or increase the velocity adiabatically. That is very important, adiabatically, when Mach number is equal to 1. This condition is called characteristic condition. Star condition is star condition. Then the properties at the characteristic condition are called characteristic properties. T star is characteristic temperature, A star is characteristic speed of sound, M star is characteristic Mach number. It is equal to V by A star. Right. Now we can derive an expression for maximum speed also, maximum speed that can be obtained by a fluid element in isentropic flow. It's coming from energy equation. So energy equation H0 is equal to H plus V square by 2, and CPT0 is equal to CPT plus V square by 2, and T0 is equal to T plus gamma minus 1 by 2 gamma r into V square. So substitute Cp, value of Cp in terms of gamma and r, you will get this expression. To get maximum velocity, what should be the condition for maximum velocity? For maximum velocity, the T must be 0. Okay, so maximum velocity Vmax is equal to root of 2 gamma r T0 by gamma minus 1. This is the expression for maximum velocity of a fluid element in an isentropic flow. Now another thing is characteristic gas speed of sound, that is A star. So in order to derive the expression for characteristic speed of sound, we have to understand that at characteristic condition V is equal to V star, and this V star is equal to A star, because at characteristic condition M Mach number is equal to 1, M star is equal to 1, that is M is equal to V by A, so V star is equal to A star. Okay, so from we are starting from energy equation. T0 is equal to T plus gamma minus 1 by 2 gamma or V square, and T0 is equal to, if you substitute second condition as star condition or characteristic condition, T star plus gamma minus 1 by 2 gamma R into V star square. So V star square is equal to 2 gamma RT0 by gamma minus 1 minus 2 gamma RT star by gamma minus 1. So we will get finally expression will be V star square is equal to gamma 2 gamma RT0 by gamma plus 1. Okay, so this is equal to A star, which that is characteristic speed of sound, which is equal to root of A star is equal to root of 2 gamma RT0 by gamma plus 1. Okay, and we can rewrite this gamma RT0 as A0, that is stagnation speed of sound or speed of sound in stagnation condition. Then A star is equal to root of 2 A0 by gamma plus 1. Okay. Now in order to simplify the problems, we will define some speed ratios, that is, one is A star by A0, which is ratio of characteristic speed of sound to stagnation speed of sound. If you put the values, then you will get root of 2 by gamma plus 1. Similarly, V max by A0 is equal to root of 2 by gamma minus 1, and V max by A star is equal to root of gamma plus 1 by gamma minus 1. I leave this as a homework or assignment. You have to complete this or complete this as an homework and submit it to the Google Classroom. Now the next topic is adiabatic ellipse. See, from energy equation we can deduce an expression for or equation of ellipse, that is from energy equation. First of all, we write like this: CPT0 is equal to CPT plus V square by 2. Then CPT0 is a constant, because stagnation condition always constant. So we can write V square by 2 plus gamma RT by gamma minus 1. Cp is equal to gamma R by gamma minus 1. So gamma RT by gamma minus 1 is equal to a constant, which is equal to V square plus 2 into A square by gamma minus 1 is a constant. And we apply a condition: if T is equal to 0, that is temperature is equal to 0, A is equal to 0, then V is equal to velocity is equal to maximum. So if you substitute this condition, you will get C1 is equal to V max square, and completing the equation with the value of C1, then we will get V square plus 2A square by gamma minus 1 is equal to V max square. And again we divide throughout with V max square. We will get V square by V max square plus 2 by gamma minus 1 into A square by V max square is equal to 1. Okay, so again v square by v max square plus what is a square by v max square, or v max square is equal to 2 gamma r t0 by gamma minus 1. So substitute this value here, then gamma r t0 is a0 square and 2 by gamma minus 1 cancels, then final expression will be v square by v max square plus a square by a0 square is equal to 1. This is an equation of ellipse. This ellipse is called adiabatic ellipse. So this is an adiabatic ellipse. The Mach number here is related to the slope of the ellipse. Okay, so here if you draw a line with a angle 45 degree to the horizontal or vertical, at that point, at the meeting point, then there m is equal to 1, because v is equal to a, v by a is equal to m, v is equal to a, then m is equal to 1. So in order to prove the relation between m and slope, do some sensitive analysis starting from our equation of ellipse. The equation of ellipse is v square by v max square plus a square by a0 square is equal to 1. Then rewrite this: a square by a0 square is equal to 1 minus v square by v max square. A square is equal to a0 square minus v square into a0 square by v max square. Differentiate this, you will get 2a dA is equal to minus of a0 is constant, because in stagnation condition t0 is a constant, minus of a0 square by v max square into 2v dv. So again 2a into dA by dv is equal to minus a0 square by v max square into 2v. And we know that the ratio of a0 square by v max square is equal to gamma minus 1 by 2. So substitute gamma minus 1 by 2 here, we will get 2a into dA by dv is equal to minus gamma minus 1 into v. So dA by dv is equal to minus gamma minus 1 by 2 into v by a, or minus gamma minus 1 by 2 into m. V by a is equal to m. So m is equal to minus 2 by gamma minus 1 into dA by dv. So this is the relation between Mach number and slope of the ellipse. And this is the first quadrant of the ellipse. See, according to the Mach number, we have divided this portion into 4, actually 5. First of all, if m is less than 0.3, we will treat that region as incompressible region, and m is in between 0.3 and 1, that is subsonic, and from 1 to 5, m is 1 to 5, it is called supersonic, and m beyond 5 is called hypersonic. And there is a small region between 0.8 and 1.2, which is near to the sonic condition, that is m is equal to 1. That region is called transonic region. So this is the inference from adiabatic ellipse. Okay. Now there are different forms of energy equations depending on the control volume we take. So here in first case, W and Q, work transfer and heat transfer, is equal to 0. Then the equation becomes H1 plus V1 square by 2 is equal to H2 plus V2 square by 2. Okay. Then CPT1 plus V1 square by 2 is equal to CPT2 plus V2 square by 2. and CPT is gamma r by Cp is gamma r by gamma minus 1, and gamma r T1 is equal to A1 square. So it becomes A1 square by gamma minus 1 plus V1 square by 2 is equal to A2 square by gamma minus 1 plus V2 square by 2. Okay. So again we know that A square is equal to gamma into P by rho. P by rho is equal to RT. So we can write A square is equal to gamma into P by rho. So the equation becomes A1 is equal to gamma into P1 by rho 1 into 1 by gamma minus 1 plus V1 square by 2 is equal to gamma by gamma minus 1 into P2 by rho 2 plus V2 square by 2. Okay. This is the first alternative form of energy equation, and another form we will take state 1, any arbitrary state, and 2 characteristic condition at characteristic condition. So the equation becomes A1 square by gamma minus 1 plus V1 square by 2 is equal to in characteristic condition this becomes A2 and V2 are same. Okay. At characteristic condition M is equal to 1, then A is equal to, or A2 is equal to V2, or A star is equal to V star. So substitute that here, V2 is equal to A star, we will get gamma plus 1 by 2 into gamma minus 1 into A star square. This is another expression. And if you take an control volume like this, that is in the third figure, state 1 is any arbitrary condition and state 2 is stagnation condition. The equation becomes A square by gamma minus 1 plus V square by 2 is equal to A0 square by gamma minus 1. And from characteristic condition, state 1 as characteristic condition and state 2 as stagnation condition, we will get another expression like T star by T0 is equal to 2 by gamma plus 1. So any property, ratios, we can express it in a non-dimensional number gamma and R. Okay. Now T star by T0 is equal to 2 by gamma plus 1, then we can write P star by P0 is equal to T star by T0 raised to gamma by gamma minus 1, which is 2 by gamma plus 1 all raised to gamma by gamma minus 1. Rho star by rho 0 is equal to 2 by gamma plus 1 raised to 1 by gamma minus 1. And the final expression is 1 is any arbitrary state and 2 is star condition or characteristic condition. Here the relation between Mach number and characteristic Mach number of any arbitrary state and characteristic Mach number is derived. Okay. So the expression finally gives us M square is equal to 2 by gamma plus 1 by M star square minus gamma minus 1. Okay, this is the relation between Mach number at any arbitrary state and Mach number at characteristic condition or characteristic Mach number. Okay, so you have to find out what is the expression for M star square. Okay, and what happens if M tends to infinity. Okay, if M tends to infinity, we will get a specific value for M star, characteristic gas concentration, that you have to find. What is the characteristic Mach number of air gamma is equal to 1.4 when Mach number tends to infinity. Okay, that's all for this class. Thank you.